Uh, yes, welcome to software training session 1. Hopefully we'll get through session 1 and session 2 today. This is meant to be an all-encompassing intro to software, to Java programming. We're going to start with some pretty, what might seem like pretty simple ideas, but we'll move through them pretty quickly, and then we'll get on to actual Java programming, and then eventually things that are specific to FRC. So, first of all, the agenda for today is that we're going to start with programming concepts, then we'll talk about Java in particular, a few different types of errors, a thing called procedural decomposition, which I'll explain later, and then we'll go through a couple of examples. So the first question is that we should ask is, what's a computer? And you could say that a calculator could qualify as a computer because it has microchips, it has programs that actually run on it. It's computing something, it seems like a computer, but in general, when we say computer, we don't mean something that is only running things that it came with from the factory. It's something that we can program ourselves, or someone somewhere can reprogram. A calculator, unless you're dealing with like a really cool graphing calculator, can't really be programmed. Although, I don't know. Some of the graphing calculators are super advanced now. Save your questions for the end. unless there's something you truly don't understand.
I don't understand why we can't.
You don't understand why we can't have Hot Wheels computers? Okay,
Yeah.
We'll look into it. With like Pentium 2s. Okay, so what's a program? A program, when we say program, what we mean is it's a set of instructions that are going to be performed by a computer. That's the simplest way that you can put it. And how do computers talk? How do we make the programs? How do we tell them to do the programs? Well, everything in a computer language is expressed as a sequence of numbers. Sequence of digits are what make up those numbers. And computers only understand 2 digits. They speak in binary. The only 2 digits they understand are 0 and 1. And we call that base 2. In common usage, we use 10 digits, 0 through 9. That's base 10 or decimal. There's a couple others like base 8 and base 16. Mostly base 16 is something that comes up in programming. Base 8 doesn't really so much. And we really won't have to do base 16 stuff for our purposes. Here's a few examples of binary numbers and their decimal equivalents. You can see that everything's the same when you get to all the way to 1, but once you get to 2, it gets different. Decimal 2 is 10, and that's an old, really stupid programming joke that there's only 10 kinds of people in the world, those who understand binary and those who don't. It's not a good joke. I have no good jokes today. But you can see that I've underlined a few of these, and the reason why I've underlined them is because there's a pattern. You can see that 1, 2, 4, 8, and 16 are underlined, and then their binary equivalents are somewhat similar. It's a 1 followed by a series of zeros. The first one is 1 followed by 0 zeros, and then it's 1 followed by 1 0. Then for 4, it's 1 followed by 2 zeros. For 8, it's 1 followed by 3. For 16, it's 1 followed by 4 zeros. And those zeros represent powers of 2. So if you take 2 and you raise it to the 0th power, you get 1. That's just a mathematical identity. We don't have to go over it. But if you take 2 and you raise it to the first power, you get 2. And if you take 2 and raise it to the second power, and if you look on the table here, there's 2 zeros after 4, you get the number 4, and then so on and so forth. 2 raised to the third is 8, and that's why there's 3 zeros after the 1 in binary for that, and then the same for 16. So what's a bit? Bit comes up a lot when we're talking about whether something's 8-bit, 16-bit, 32-bit, 128-bit. During the console wars back in the day, there was like argument about who had the most bits, and whichever consoles had the most bits were better. A bit is short for binary digit, which is really lame, but that's just what it is. If you think that's bad, you should hear what they originally wanted to call it. I think they wanted to call it a bidget, which is just rolls off the tongue. A byte, that comes up a lot in programming as well. A byte is 8 bits. So if you have 8 bits, that makes up a byte. What's a kilobyte? You'd think it's 1,000 because of the metric system. It's not, for stupid historical reasons. The closest you can get to 1,000 with a power of 2 is 1,024, and that's 2 to the 10th power. And the megabyte and the gigabyte are 2 to the 20th and 2 to the 30th, accordingly. There was a whole lawsuit over whether or not it's 1,000 bytes or 1,024 bytes, because Windows would display your storage, your hardware size in one amount, but the hardware manufacturers would sell on the box, they would say it's a different size because they were using like one was using 1,000, one was using 1,024. So people would go to the store, buy these nice cool hard drives that said this many gigabytes, take them home, plug them in, and then Windows would say, actually it's less. And both were right, but someone was actually kind of being deceptive in marketing. Okay. Anyways, why should you be here? Why should you learn to program? Maybe you like code already, and then I don't have to justify it. But even if you don't want to code, if you don't find anything really cool or interesting about the code itself, it's a tool, and it's a tool that you can use to solve really difficult problems. And solving difficult problems is fun. Solving easy problems can be fun sometimes, but it's the hard ones that give you the most satisfaction. Your solutions for difficult problems are going to take the form of instructions for the computer, and your instructions to the computer are always in a series of steps. And all the steps needed to do a task, to accomplish your task, are what are called an algorithm, which is like an old, I think it's an Arabic term, but I'm not positive. Okay, so the process of computing, or of programming, starts with writing the code and then executing the code. And executing doesn't mean we kill it. It means that we run it. Execution means that you're running something, like Steam is running, Steam is executing. Yeah. Sometimes you may want to kill your computer. Okay, and sometimes it seems like your computer is killing your programs. So what kind of language do computers speak? They speak in ones and zeros, as we've already established. This is machine code right here. This isn't something I made up. This is an actual portion of a program that some human wrote. And this was originally how they programmed computers. All these sequences meant something, and the order that you put them in meant something, and it's a nightmare. I can't believe anyone did it, but my hats are off to them, and we don't have to do that. Along came something a little bit better, and that was called assembly. Assembly translates into machine code. So everything you see on this screen right here is equivalent to the machine code. It is the exact same program as this. But it's written in words that are kind of decipherable. You can see some of these are like English, and that's a real English word. Add at the very bottom, that's a real word. R1, R5, R4, those refer to registers, but we don't have to do this. Like, this is still, assembly is really difficult to do. I haven't done it since college, and unless you're someone who really wants to optimize things incredibly, assembly is not really an important tool to use. It's important for some people to learn, but not for you. So what we use is a different kind of program, or a programming language. It's a programming language that's not as close to the computer's native code. So assembly is what we would call a low-level language because it's close to what the actual computer is speaking. It's fairly similar to machine code. It translates pretty easily. But we want to use high-level languages because they're a lot easier for us to read and write. And so along came languages like C, which is a high-level language. And you can see that these words are almost all words that you know. Even if you don't know what the program is, these words make sense. Include, define, last, main, sum. You can figure these out. Print, F, maybe you don't know what the F means, but print means something. Return, okay, these are actual words that you can like figure out the definition of, and once you've learned how to program in C, you can write C programs, and it's a way easier process to write and read them than it is to write something in assembly. So how does a computer understand our program? Well, Anything that's not machine code gets sent to a special program, and the program converts it into machine code. And that program that does that is a compiler. Compilers compile source code, code that you write, into machine code that the actual computer can understand. Every machine has a different machine code. And if you went to the store and bought like 2 laptops that were the same model, they have the same machine code. But the laptop you bought today, that compared to the one that you bought like maybe 10 years ago, they're going to have different machine code. The phone that you have has different machine code than your laptop. Your watch has different machine code. Your microwave has different machine code. And so if you want to write a program for a machine, you need a compiler that can convert your code into that machine's code. And that means for every machine that you want to run your application on, you got to have a compiler for it. And if there's no compiler, if nobody's written the compiler, then you don't get to program that device unless you want to learn its machine code. And so this is actually this has been a difficult thing throughout the years. Programs, as computers got more and more sophisticated, their machine code got more complicated, and so you would have to recompile programs for the new machine code, and sometimes that meant like changing your code because things were different now. And it's like mismatching the compiler to making sure you have actually the compiler that's writing code that can compile to code that's actually optimized for your machine is different than one that can just compile for code that works on your machine. It's something we don't actually have to actually have to worry about because Java came along, and the compiler for Java is a very special thing. It converts, instead of converting it to machine code, it converts your source files, your code, into Java bytecode, which is intermediate. It can run on a computer that lives within a computer. And that computer is called the Java Virtual Machine, or the JVM. This was kind of a groundbreaking, fundamental, positive thing about Java. And the idea is that someone else writes the JVM. You don't have to worry about the compiler. The JVM is already written for you. You just write the Java code, and as long as the JVM works for the device, which it does for like your phone, if it's an Android device, there's a JVM for it. Your computer, there's a JVM for it. The Robo Rio that powers the robots we drive has a JVM. So you can write Java code for all of those. And all Java code has to live inside something called a class. We're going to get more complicated with what a class actually is, but for now it's just really important to understand everything has to be in a class. It's just a fundamental rule that they created. Not every programming language is like that, but Java is. And the special program that's running your Java code is the Java Runtime Environment, the JRE. There's a ton of pre-existing code that's bundled with Java. That was a huge additional selling point for Java. One was the JVM, so that developers don't have to worry about compilers and compiler versions anymore. The second is that it comes with all this pre-bundled code that does these common tasks that you can plug into your programs. You don't have to rewrite these very common pieces of code that are meant to solve tons of different problems. You can just reuse the pre-bundled code that comes with Java. It's called the Java class libraries. Okay, so the process. The process is to create or edit a source file in an editor. And if you've done Java programming before, you've done it in something like maybe IntelliJ, or for FRC, we typically use Visual Studio Code. But you don't need it. You can just use any old text editor, because the output is a hello, it's going to be a file name .java. That's actually just a plain text file with a renamed extension. And then you take your source file and you submit it to the Java compiler, and then maybe you edit it some more, whatever. But at some point you take the output of that compiler, which is a new file. It's not the same as your source file. It's an output file that it's the same name as your source file, but the extension is now changed. It's a .class, and that contains the bytecode. And then you take that output file and you execute it on the Java runtime environment. Okay, so before we move on, I'm actually going to try this. Let's see here. So Notepad has the ability to edit text files, .txt files, but you can save them as anything else. So I'm going to write a quick Java program. So this is going to be a magical abracadabra incantation. Maybe you'll recognize it, maybe you won't. Public class hello. And then we have a left opening curly brace and a closing curly brace. And I'm going to put that curly brace on a new line. Everything inside here I'm going to indent by putting 2 spaces. You don't have to do spaces, you can use tabs. In fact, you don't even need the indentation at all, but you should put it there. It indicates that we're at a different level. All right, public static void main string left bracket, right bracket, args, right parenthesis, and then curly braces again. But I'm going to line up this curly brace with the public, whoops, and then I'm going to put a new line in there. And I'm going to go to a new level of indentation. System.out.println, and then we'll say hello. All right, let's save this. We don't do everything with the command line, but it's important to at least have a competency at some point with doing command line stuff. So don't worry about this too much. I'm just doing this for demonstration purposes. So I'm going to do Java C, which is Java compile hello.java, and it's now compiled. It didn't spit out any errors, and so if I check the directory again, there's now a hello.class file. So I'm going to run that by using Java, and then I'm just going to type the name of. This is kind of an annoying gotcha. You don't have to type the class part. I'm just going to type hello. All right, and so my output was hello. Great, cool. So I got a program running, and if I change my output here, I have to go through the process of recompiling Java C, and then and now it outputs hi. Okay, great. Super useful demonstration. That's just fantastic. Let's bring it back up. Okay, so here's a breakdown of the actual class that I wrote. And you can see that let me resize my presenter view over here. The class name is hello. The name of your class always comes after the word class. And then we have grouping characters, which are the curly braces. They're always matched opening ones or rightward facing ones, and closing ones, which are leftward facing ones. They should always come in pairs. If you have an opening brace, you've got to have a closing one somewhere. A method is it's a program unit. It's like the basic building block of something that your program is doing. Not information necessarily, not data. It's more of like actions or computing. And then within a method, you have a series of statements. In this one, there's only one statement. And at the end of each statement, you will have a statement terminator in Java. In some programming languages, you don't have that terminator, but in Java, it's strictly enforced. You have to have the semicolon. The other part of this that I want to call out right now is the hello surrounded by quotation marks. That is what's called a string literal, or more commonly just a string. It's a sequence of text characters, and you can conceptualize it by thinking of like those party banners that's a string with letters hanging off of it. That's what it is. It's a series of characters that are grouped together, and we will be using those a lot. So for string literals, there's special rules. They have to be surrounded by double quotes, and they cannot span multiple lines. So you can see single quotes, it's not valid. If you have single quotes within double quotes, that's fine. And if you try to put a line break in the middle, nope, that's gonna not compile. Java does not like that at all. So what can we do with strings? Well, the simplest thing that we can do with them is output them. And we do that in Java by using this special method that you access via system.out.println. It's a very simple and common Java statement. It's something that we're going to start out with and it prints out a single line. That's what the LN is short for, to the console output of your program. The parentheses are required, but if you want to just print an empty line, you can just leave them empty, and then it'll just print an empty line. So that kind of raises a question. You can print any character you want, except for a few. In particular, like, how do you print out something that has a quotation in it? Like, what if I wanted to print out hello surrounded by double quotes? Java's going to actually not like that, because when you put the hello and you have those two quotes next to each other, it's going to think that's the string, and then everything after it is going to mess up the compiler. So we have to use a special character before that to create an escape sequence. It's just kind of a stupid, annoying legacy thing. But if you want to use double quotes, you have to precede it with a slash, a backslash. You can put in tab characters, which are just tabs. Those are actually counted as characters. You can put in a new line character, which in a text file is actually considered a character. Spaces are characters, but they don't need to be escaped. And then a backslash itself has to be escaped, because we're using backslashes to escape other things. So yeah, it's fun. Identifiers are names in Java. So anything in Java that you want to refer to later, you give it a name, and those names are called identifiers. There's different rules that apply to identifiers. One is that they always have to begin with a letter in Java. You can use a combination of letters and numbers after that first letter. You can also use underscores and dollar signs. I would not recommend using dollar signs. And the underscores, those are okay in some circumstances, but we generally avoid them. There's specific places that we'll get to later where we use them. These are some legal identifiers. Hello underscore there. $20. Starting underscore size. Actually, $20. Actually, I'm not sure that's legal. And then max underscore weight, all caps, that's legal. Illegal identifiers, they can't have spaces in the middle of them. You can't have a name that has a space in it. You can't have a plus sign, a dash, and it can't start with the number 5. Or any other number for that matter. Nothing specific about the number 5. Okay, so there's some general conventions. You can violate these and your program will run, but people reading it aren't going to like you very much if you violate these. Classes should always begin with capital letters. So when I wrote my original program, public class hello, that's a capital letter, just for the first one. Methods can begin with lowercase letters, and you can see in the public static void main, that's a lowercase letter that it begins with. And that's just a convention that we use. Like I said, the Java compiler won't enforce that, but you should follow it. And then if you have multiple words, then you should use what's called camel case. So every word after the first word should have its first letter capitalized. There's also some tips that you should follow. Java is case sensitive. So if you name it one thing that begins with a capital letter, and then you try to refer to it later with the same word but lowercase, it's not going to work, and you might get annoyed and confused by that. And you should use descriptive names when you name things. Don't name it method 1, method 2, method 3. Like, someone's going to read your code in the future, including like the future version of you, and not understand what you were thinking. And then there's some things that are, there's these things called reserved keywords. You're not allowed to name things these words, and there actually might be some more. And you don't have to memorize them, but things like for, else, you may recognize those. Also class on the first column towards the bottom, that's a reserved keyword. We've already seen that. You can't name something class. You can't name something void. We've already seen that in the code. That's a Java reserved keyword. That's for Java only. Readability. You should put class and method headers on their own lines. Yeah, and what I mean by that is when I said public class hello, that should be on its own line. You could have put like immediately after that public Here, let me show you. This second line of this program, you could actually put it right after that opening curly brace on line 1, and it would still compile and run, but then you have a super long line that's annoying to read. So generally put like class names on their own line, put the method names on their own line. You could also, in this case, take that system.out.println and put it right after the curly brace on the line previous, and it would still compile and run, but similarly, that's not good. Indent your code correctly. Oh yeah, this is also something that's not enforced by Java. So there's some languages like Python where indentation is important and enforced. Like if you indent a different level, it won't be treated the same as other levels. But in Java, you can use whatever indentation you want. But you shouldn't want to use weird indentation. Always put increased indentation after a curly brace, and then after a closing curly brace, decrease the indentation, and you should be consistent with your indentation, like do it in levels of 2 or 4 spaces. There used to be an argument between using spaces and tabs. I don't know, there might be some bitter people who still clutch to tabs, but most people don't use tabs anymore in software or in source files. And it's okay to use blank lines. The blank lines are ignored by the compiler, and they can make things easier to read if you want to like put gaps between methods or whatever in order to show like this is distinct from that. These don't all go together. Comments. Comments is text within a program that's used to explain the code. It's for humans only. The compiler and the Java runtime won't pay any attention at all to your comments. They're just inhaled and spit out the same. Nobody cares. But the people reading your code care. Not everything you write needs a comment, but certain things do warrant a comment. You can say like, I'm going to clean this up later, and then you never will, because that's how that comment usually goes. But if you want to like warn somebody, don't change this unless you know what you're doing, or if you change this other thing over here, or this is what this is supposed to do. Those are valid comments. And the first type of comment is a multi-line comment. It starts with a /* and ends with an */. So nice symmetry there. You can actually create a single line comment with the multi-line comment format. Just put it all in one line. But it's better for when you're doing multiple lines like this second example. And when you do it, it's a good practice to make sure your indentation lines up with the first line for every subsequent line after that. Spaces are not allowed. If you put a space between the / and the * on either end or both ends, that's no longer a comment, and your program will not compile. If you don't want to write multi-line comments, you can write single-line comments, which are just a //, and they can actually be on on a same line with code as long as they're after the code. If they go before the code, they will turn that code into a comment. You can do multiple lines with slashes, but it's kind of tedious because each line requires the double slashes, although IDEs make that a little cleaner. It's still not like the best way to do it. Here's a couple of tips. Put your comments right before a class, or put a comment right before a class, just giving a super brief description. This is what this does, and your comment shouldn't be literally the class name. It should be like, this is the collector, or this is the input-output for the collector, or something like that. Put them right before methods as well. Some methods don't necessarily need a comment if they're super simple, but a lot of them can use it. And that sums up our intro to Java, but now we're going to talk about errors. Errors are inevitable. To program is to make mistakes, and your mistakes are going to surface as errors. There's different categories of errors. The first category is a syntax error. It's essentially a grammar mistake because the language that the computer speaks, well, the language that the compiler speaks has its own grammar. And if you violate the Java grammar, then the compiler doesn't know what to do with it, and it's just going to fail to compile. So your program literally can't run because it can't. The compiler will reject it and say, "I'm not turning this into a program." Common types of syntax errors or bad spelling. You can typo things like println. Println is not a method; it's println. You might also fail to capitalize something. It's supposed to be capital S system.out.println, and that's kind of a little bit more difficult to understand what you've done. Println really stands out, but like this one would be easy to overlook. Another very common type of syntax error is to like forget your line terminators. If you don't put the semicolon on, Java compiler will complain. Some programming languages don't include them, and some people think that that's better. I think it is, but that's just what Java does. Okay, another type of common syntax error is just forgetting a required keyword. So if I was to write public hello, that's not valid. I have to say it's a class by putting the Java class keyword before hello. That's a super common mistake. Another really common mistake is that you've started a string with a quotation and failed to close it. This one's actually, the error is actually really helpful. It says unclosed string literal. So yeah, that's really a great error. It tells you exactly what you did wrong. The second type of error is a logic error. So your program in this situation is compiled. It's running. It's a valid Java program, but it does something wrong. These ones are difficult because it can take some time and attention to fix. Like your error may show up in an inconvenient time. So always double check what you expect your program to do versus what it actually does. And if you have like a mismatch, if it's not doing what you think, then you got to read the code. The last type of error is a runtime error. These are crashes. So a crash is a runtime error. Runtime error is a crash. In these situations, your program compiled and ran, but something really bad happened and it crashed. And you may think like crashing is the worst thing that your program can do. That's not true. Like it would be bad if your program like damaged your computer, or if your program like cost someone a lot of money or ruined the robot. Like sometimes it's okay to crash. It's really good to crash if the alternative is doing something that's not fixable with code. You can cause problems with code that you can't fix with code. Okay, and then our last subject for this session 1 is procedural decomposition. This is the essence of programming, and what it is just a fancy term for breaking down big problems into smaller, simpler pieces. Nearly any problem can be tackled this way, and it's not just something that you would use for programming. It's also, we have this concept called iterative development, where we create a program in stages. Each stage we add a new piece of functionality, and this allows you to test your program at each stage. And this is highly recommended rather than trying to write the entire program at once. If you write the entire program at once, then when you try to run it, if it works great, then you're awesome and everyone loves you. If it doesn't work, then you've got to figure out what part of your code didn't work. And if you haven't tried it out at this point, then it could be any part of it. It's hard to find mistakes. Okay, static methods. So this is our fundamental, our first building block for procedural decomposition. So it's a method is a named block of Java statements. It's just a group of statements that get executed together, one after the next. And this allows us to move code out of the main method, which is also a static method. But not everything has to be in your main method. For example, if I was to have this program where I print 2 squares, This code actually, if that's what I want to do, that's great, but it's kind of redundant. And we don't like redundant code. If we're doing the same thing in multiple places, that can cause errors later if we want to change the way it's done. You may forget to, you may change it in one spot and forget to change it in the other. And that's why we always look for the redundant code. And we follow the DRY or dry principle. Don't repeat yourself. If you see something that's the exact same, then that's an opportunity for extracting it into a separate method. So in this case, we create a method called drawBox, and we put the drawing box lines in it. And the different aspects of this method signature are public, static, void, and then there's a name, and then there's empty parentheses. So public means that this method can be used anywhere in your program. Static means it's not object-oriented. Java is an object-oriented language, but we'll get to that later. Void means that this method doesn't compute and emit anything, or doesn't return anything. DrawBox is the name, it's your identifier. And again, for methods, we use lowercase identifiers. And then the empty parentheses, within that, those two parentheses, we put the list of values that go into this method. In this case, we don't need input, there's nothing.
So the last one, when you printed hello, the main method, is this the name you gave, you could call it anything, I guess?
The main method is a special method that Java requires program to have. So if you change the name of your main method, it will no longer be invoked by the Java runtime. It's just a standard thing.
Gotcha. You're repeating yourself. On the print line, you have two.
That's true.
Print lines.
We'll get to that.
Okay.
Okay. So procedural decomposition. We've created a method named drawBox, and we want to call it. A method call is a way that we can do that, and it's simply a statement that executes another method. It causes all the statements within that method to be executed. You do it by just using the method name, and then you have to add the parentheses. Even if, in this case, our method doesn't take any input, that input is just empty. Left parenthesis, right parenthesis, empty input. So yeah, this is what that would look like. And you can see here that we have a main method still, but within the main method, we call the method drawBox, and then we print an empty line, and then we call drawBox again. And our drawBox method is what draws the box. So we've done the same thing we did with the first program, but now we've reduced the redundancy. Not all of it, but we've reduced it enough. In this case, drawing that box, the benefit of having it in one spot is that we can change the shape and size of the box once, and it will change the output every time where we've invoked that method. Order doesn't matter. So drawBox can be above your main method. In general, we put the main method first just out of convention, but it doesn't have to be first. And that kind of raises another concept that we need to talk about, which is flow of control. The order in which statements are executed. Programs don't always execute top to bottom. The execution point actually jumps around. It's generally top to bottom within a method, but even that can change. All right, let's see here. I have an example that I need to do. And this is going to be super confusing. And the question is, what does this output? So if you look at the first line, the first starting point of this is that it's going to execute our main method. That's just what Java does. It looks for your main method, and here it is. So what's the first thing in our main method? It's foo. That's the first statement. And so let's follow that execution point from foo to the method named foo, and it's going to print the word foo, And then it's going to invoke the word mumble. So let's actually output this line by line. Oops. All right, so start at main and then foo. And then what does foo do first? It outputs the word foo. Oops. And then it's going to call the method what? Mumble. All right. And then what does mumble do first? It's at the very bottom.
Outputs mumble.
Yeah, it outputs the word mumble. Output. And then there's nothing else in mumble. So we go back up to the foo method. So we call mumble, and then what do we do?
Just print an empty line.
Yep. Output empty line. All right, and then after we output the empty line, what happens?
It goes to bar.
Right, so we go to bar. What happens within bar?
Outputs bar.
Outputs bar. What's next?
Goes to baz.
All right, so we go to our stupid method called baz. And then what happens in baz?
Cleans out baz.
All right, and then what else does it do?
And then goes back to mumble.
All right, mumble. And then within mumble, we've already encountered this one. What does mumble do?
Outputs mumble.
Output. Like me, outputs mumble. All right, and so at this point, mumble has completed, so we go back to baz. What happens after the invocation for baz for mumble?
Nothing.
All right, nothing, so it goes back up to bar,
And nothing.
and then nothing, okay, and then it goes back to main,
And nothing.
nothing. Okay, so we would expect our output to be foo, mumble, empty line, bar, baz, mumble. Fantastic, really useful program. Really, really nice. Let's see if it actually works. Foo, mumble, empty line, bar, baz, mumble. So we Java C the program first, and what did we call this? Foo, yeah, okay. And then we run it. Foo, mumble, empty line, bar, baz, mumble. Great. We are geniuses.
Yay.
Yeah. So this seems useless, but this is a process that you're going to have to do when you're looking through programs. Is you're going to have to follow the execution. You're going to have to like, okay, this method calls that method. What does that method do? And okay, now it's done. So I need to go back to the method that called it, and then so on and so forth. Seems like a kind of annoying process, but it's surprisingly common.
The process in the robot is main run the actual main, and then it goes in all the other things. And
Yes, actually, you can find it in the source code. It actually has a literal main method. Like if you're writing an Android application, there's no main method. It's sort of like kind of synthesized by the Android Java runtime, and it's what's called an entry point. It gives you a different entry point into your Java or your Android app. But for us, the entry point, even for an FRC robot, is going to be a main method. All right. So we want to we want to create a program that outputs this exact thing. And it creates like a this weird stuff up top, a cone and then an X and then a rocket, and then Musk, Bezos, they're fighting over this rocket, or maybe they built it together. I don't know. I didn't really think about this example very much. So, yeah, let's start out. Let's create a new program. Let's call it draw figures. Whoops, classes do not have left parentheses and right parentheses. So we have the public class, and then we increase the indentation, public static void main, left parentheses, right parentheses, and then this is just something Java boilerplate that we'll figure out. We may never actually get to what this means, and that's okay.
Is it there every single time?
What's that?
Is it there every single time?
Yeah, unfortunately, it's just sort of like almost like an appendix. It's I guess I can explain it. So the args is short for arguments. When you launch a Java program, you can pass in command line arguments that are not precompiled into the program, and they'll be in this string array. We'll get to arrays too. Okay, so we want to create this rockets. So I guess we could start by trying to print. I guess I don't want to drive the discussion here. What's repetitive here? If we want to follow the don't repeat yourself paradigm rule, what are the shapes that we can extract out of this to not repeat ourselves?
Probably the cone
Probably the cone.
at the top.
This thing here.
Yes.
Okay.
That's there. You use it like 3 times.
That's right. So it's there, 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 and there. So we draw the cone.
And then maybe some the box or some part.
So I'm going to copy that. We'll start by like draw cone, or we'll create a method and then call it draw cone. Public static void draw cone. And you see that began with a lowercase letter, and I followed the camel case. All right, fix my indentation, fix it again. System.out.println, but we want to actually print a thing. This is where it gets a little weird. We want to print this. So let's try starting with that. So that's-
Wait, that'll go immediately to the bottom and all the way to the left.
okay, so we should print that. Okay, we'll do that. And we're going to do this step by step. Draw cone. So we're not going to have a whole cone here. Whoop. Draw figures.java, and we will compile it and run it. Java C draw figures.java. Boom. Unclosed string literal. What's this mean?
Oh, is it because of the tab?
Oh. That rule with the.
Yeah. So this is a really confusing error because it says it's an unclosed string literal, which usually would mean you forgot a quotation mark. But when you look at it, it's like, no,
Oh.
I have 2 quotation marks.
You have to put the
Do you remember
the
our...
extra slash.
Yeah, we have to use our escape sequence.
That's annoying.
So let's see here. Where'd it go? I guess I don't need to reopen the whole thing. The escape sequence for a quotation, for a double quotation mark, is literally that, the
So you
slash.
need to put another slash to make sure it's
Correct. So we have to escape our slash. Cool. And then we'll run it. Java draw figures. Ah, okay, so we have the tip of something. Let's do some more. Let's get more of this. Whoops.
What did you do?
Let's get more of our rocket.
Let's just copy the whole line.
Copy that.
Yeah, and then keep going farther out.
Okay. So we delete, and then we want to line up this other one, right?
Mm-hmm.
Okay. And I think we can just finish this draw cone. We'll delete a space, add a space, add 2 spaces this time. All right, save that. And now that's what we wanted, right? 1, 2, 3, 4. Let's try it out. Java compile and Java run. Oh, it's not using my history. Cool. All right, so we got the first part of the rockets thing down.
Oh boy.
Outstanding progress.
And we have to do something for the, what was the other parts of the rocket? We have to do an inverted cone.
Okay. So let's copy that. Public static void draw inverted cone. And I used camel case again. For every new word, you just capitalize the first letter.
And then just reverse the order of the...
Oops. Reverse the order.
Yeah, but then swap the places of the parentheses. Well, not the slashes. Like put the bottom one at the top and then...
Like that.
Yes.
We're getting somewhere. That looks a little funny. Oops. I think we have to replace all these though, right?
Yeah.
The double one?
Yeah, right. It's a backslash, so we have to escape the backslashes, because if we don't escape them, then it interprets it as like that it's escaping the next character.
That should work.
That should work. All right, I'm gonna delete this and leave that empty line between the methods. Like doesn't literally have to be there, but having that empty line makes it just that much more readable.
We need the draw inverted cone.
Ah, yeah, I need to invoke the new method. Draw inverted cone, and give it the left and right parenthesis. Save it, and then go back to. We're gonna graduate out of the command line, but for now this is a good exercise. So we've compiled it, and then we execute it. Boom! We've got a diamond. Is that what we wanted to draw? What did we want to draw?
Yeah. And it has to have a line in between.
Okay.
And then it needs another draw cone underneath it.
All right. So we don't really need a new method just for printing an empty line. It's okay to just like do that. But you said we should do a cone
Wait, what,
after
what
the
does it
inverted
look like again, the rockets one?
cone.
Yeah, just immediately print another.
Actually, it's going to be like that. Oops. It'll be draw cone, empty line, draw inverted cone, empty line, and then draw another cone, right? Whoa. Oh, should I draw another cone after that?
Mm.
Compile. Oh, wrong program. Okay,
Yeah.
we are getting close. We are getting very close. So we need to do drawing the rocket body. So we could put this in a method and call it rocket body, or we could do something else.
I think what you should do is have like the line with all the pluses and the dashes and make that its own print thing.
We could.
And then the middle, the lines on either side should be their own thing. So then you can just repeat that.
I could, but then it would be like a method call. It would be one method call for this line.
Oh, just draw square.
One method call. Yeah, I think if we do the whole square as one method, that's going to be a little less repetition in our main method. All right. So let's oops, too many. Public static void draw square. Oops. 2, 3, 4. And then we want to do a bunch of drawing. We want to print out this. That shape right there. And that shape is going to be 4 lines. So let's do 4 statements. Whoops. 2. 3, 4. Okay. So what's our first line?
It's going to be the top square part.
Okay. I'm just going to copy paste it.
Sounds like a great idea.
Do you think I need to escape anything here, or should I just try it?
Do you have to escape the minus sign?
I don't know. Let's just try it out.
Are you sure you're not to escape anything?
I don't know anything. I'm new here.
Okay.
All right, let's draw this square. Java compile. Java run. Yay! So we've got a square.
And now we need to print out Musk and Bezos.
That's right. So we need to print out the body where it says Musk and Bezos.
I don't think we really need to do another square, just the Musk and Bezos lines.
Just do those in the main method.
Mm-hmm.
All right. Seems logical.
But you don't need the top and the bottom.
What's up?
You don't need the top and the bottom.
Good call. All right, so it starts with Musk, and this is actually this wasn't actually part of my talk, but when you're programming, the font that's used in the editors and the font that's by chance used by a text editor or Notepad is monospace, which means each character takes up an equivalent amount of space. So if you line up things like that, then they'll line up when you print them out. Contrary to like a Word document, if you try to like line something up, it doesn't always line up because each character is a different width. All right, so now we're going to do Bezos. And then I'm just going to delete spaces until the right-hand side lines up perfectly. All right.
And just draw another square.
All right.
And then a cone.
Draw square. Draw a cone.
Should work.
Yeah, it should work. Compile it. No errors, so we didn't need to escape anything. And, okay, is this what we wanted? So we've got a cone, space, an X, space X? Oh, I didn't even mean that.
Oh.
And then an empty space, and then the Musk Bezos Unity rocket. I'm not that clever. I didn't mean that. Yeah, I think we got it. Okay. So that is I'm actually going to go into session 2. Okay, so yeah, software training 2, we're going to talk about primitives and loops. But before we get started on that, as a review, we went over in our first session basic computing concepts, hardware versus software. Actually, I don't know if I ever talked specifically about hardware versus software. The hardware is the physical components, and then the software is the programs. We talked about digital, like binary, why programming, why Java, the process of programming, Java programming environment. We talked about basic things in Java like string literals or strings. The println method, we use it a bunch. Escape sequences, identifiers, keywords that are off limits, comments and readability. And then we talked about different types of bugs, syntax errors, or different types of errors, syntax errors and logic errors, which are generally called bugs. But then we also talked about like runtime errors, which I guess you could call bugs, but they're crashes. Procedural decomposition, that was just the breaking down of the big problem into a smaller problem. I keep getting messages about, oh, never mind. It's not important. Today, or this session's agenda is to go over data essentials, variables, for loops, code organization, and to have another example. All right, so first of all, data essentials. Java is what is called a strongly typed language. That means you have to be specific about the kind of information you're using, and it prevents a lot of certain kinds of errors. I don't know why the bottom of my screen is, that's odd to me. Was it like that through the whole previous session?
No.
Oh, now it's gone. Okay, cool. I fixed it.
Yeah.
So, yeah, primitives are, so Java, oops, I clicked the screen and it changed. So, having a strongly typed language, it prevents certain types of errors. It's kind of a trade-off. There's no actual, there's usually not solutions, there's usually just trade-offs. There are lots of languages that are weakly typed or not typed at all, and allows a lot of flexibility. But it also allows a lot of like shooting yourself in the foot. So yeah, Java went away, down a certain path where everything is strongly typed, and it forces you as a developer to comply with certain things and to be very explicit. And it eliminates a lot of certain types of errors, but it also gets rid of the flexibility that you see in some languages like Python. Java has 2 main categories of data. It's kind of a pain, but we have to learn both. The first is objects. These can be really complex pieces of data, and they can have logic within them as well. We'll get to them later. This is like the big selling point of Java, but before we get to objects, we need to talk about primitives. Primitives are very simple, hence the name primitive. And we have to treat them differently than objects, which is annoying, but we just got to do it. So, primitives. There are lots of different kinds of primitives, but the 4 most important ones are integers, doubles, characters, and Boolean values. Integers, in Java, we use the keyword int. Double, it refers to a double. Char refers to a character, and Boolean refers to a Boolean. Integers are whole numbers, probably learned that in math. Doubles are decimal and whole numbers, they're real numbers. Characters are single characters, they can be numbers. Numbers can be characters. Anything can be a character, and as long as it's a single character. And then Boolean only has two possible values. It can be either true or false. And there's no in between. So why is there, this kind of raises the question, why is there more than one type for numbers? I said there's integers and real numbers. That's because integers are exact. They're exact up to a certain size, which leads to certain types of bugs. But they are very precise. Doubles get cut off at a certain point. If you've, you may have noticed this in your calculator. Sometimes, like you'll do like one calculation, and then you'll try to undo it by doing like the inverse numbers and opposite operations, and you get like a different number than what you started with. That's because the number got cut off at a certain point. Doubles, even though they represent decimal values, a lot of decimal values will repeat or they're infinite, and doubles can't handle infinity. They just go out to a certain point and then they just drop everything after that. And the reason why it's called a double is just kind of a stupid quirk of history. It's twice as accurate as a different decimal type, which is called a float. We won't probably ever need to use floats. But if you ever see the word float, that's also a decimal value like a double, but it's half as precise. All right, and that brings up the concept of expressions. It is an expression is a simple value or a set of operations that produces a value, and they can be like mathematical expressions. So 2 times 6 plus 4 times 4 plus 2, that's an expression.
28.
What's that?
It's 28.
Nice job, I hope. This will get evaluated into a single number. Yeah, if you're on Facebook, you see these dumb things like only geniuses can figure this out. So yeah, the process of obtaining a value from an expression.
Wait a second. 30, right?
You're right. It's a typo. Well, imagine it says 30. Yeah. So when we take an expression and we evaluate it, we get the actual value. So expressions themselves aren't evaluated. The expressions are evaluated. They're not used. They have to become, or they have the Java runtime will evaluate your expression before it actually uses it for whatever you're trying to use it for. Okay, where's my window? There it is. Oh gosh. So operators are a part of an expression. There's special symbols that are used to indicate an operation, and they are performed on one or more values, which are called the operands. The operators in this expression are the asterisk, which is multiplication, the plus sign, which is addition, and then the operands are the numbers that are being operated on.
Wait, this is just math.
It is just math. It's all math.
You're making us do math.
Well, that's programming is math.
Oh, no.
Literals. So we've already talked about string literals. Literals are just simple single values. There's nothing to evaluate. It's literally that. So if you're talking about an integer literal, it could be something like 42, -3, positive 18. You can actually use the positive sign on these different literals, and it won't be an addition. Like you can use that as a number, 18 as a number with a plus before it, and it won't give you an error saying that I don't know what to add it to. Doubles are the same way. You don't have to have a 0 after or before the decimal place. You can actually just leave it off, and Java will be fine with it. You can also use scientific notation, although in general, that's not really necessary. Characters. We've already talked a little bit about characters. Well, yeah, we have. Strings are made up of characters. They can be a single piece of text. They can also be a number. And if you're using certain characters, you have to escape them, which is dumb. but you just gotta do it. And then we've already talked about Booleans. They're either true or false, no truthiness or falsiness. There are operators that represent arithmetic, and most of them are obvious: addition, subtraction, multiplication, and division. But the one tricky one that you should keep in mind is the mod or remainder operation, and it's represented with the % sign. And it simply takes the result of a division operation, or the remainder from a division operation, but not the quotient. Integer division is a fun concept. When you try to divide two integers, the result is going to be an integer, but if it doesn't divide evenly, then it will just discard everything after the decimal place. It won't round it up, it just cuts it off and throws it away. So if you're trying to say 19.0 divided by 5.0, that's great, those are both doubles, you'll get 3.8. But if you do 19 divided by 5, you're going to get 3. If you do 19 mod 5, you'll get the remainder. Precedence is pretty much not very surprising. Expressions are evaluated in steps, just like you have to evaluate them in math class. Java's order of operations, it matches what you've learned. But use parentheses to override precedence. If you want, like in this last expression, if you left those parentheses off, it would just evaluate them from left to right. But if you put the parentheses around the last two operands, then it evaluates that thing first, and then it will perform the subtraction. So you can get totally different values if you include the parentheses. There are also these things that are different types of operators. The unary operators, these are the ones that I've already talked about, where you can put a plus before a number and it's not an addition, it's on one single number and just means it's positive. If you leave the plus off, then it's assumed it's positive. And if you use a negative, then it's negative. There are multiplicative operators that are done next. So this is evaluated top to bottom. So if you have a -5, that will be evaluated before you do any multiplication. Or I guess in mathematic terms, the negative sign follows the 5. And then the last thing it'll do is plus and minus. And it evaluates them just like in math class, left to right. It doesn't do plus first and then minus. You can perform arithmetic with integers and doubles together, mixing them, but be careful. Java is always going to treat the int as a double in this case. So 23 divided by 4 is 5, but if you do 23.0 divided by 4, you'll get 5.75. And if you mix and match all these different ways, you're going to get 5.75. It essentially, the concept here is that Java is created in a way that it won't lose information on purpose. So if you're doing something, if you're going this direction from an integer to a double, which is going to have, an integer is never going, or a double is never going to lose accuracy if you try to put an integer into it. It'll just have 0 after the decimal place. So that's okay. If you want to convert a type, you need to, like without doing an operation, you need to cast it. And this is when you put the type that you want it to be in front of the expression, and then you surround that type with parentheses. So if you cast 4.75 as an integer, you'll get 4. If you cast 4 as a double, you'll get 4.0. So be really careful with casting. This is not intuitive at all. The cast only applies to the thing that's right next to it. So if you try to say 2.5 divided by 0.16 and cast that as an integer, Java is going to interpret that as cast 2.5 as an integer and then divide that by 0.16. And then it'll convert and then the value at the end will be a double. when in reality what you probably meant is the second thing, which is evaluate this whole thing, the division, and then cast the result as an integer. Okay. Variable. A variable is specifically, it's a memory location. When you declare a variable, you need to give it a name and a type, and it will tell Java to reserve a place in memory for a value that you are either putting in right now or you're going to put in later. So in this method, in the main method of this program, we have created 3 variables: miles, hours, and miles per hour. And then after we've declared them, we assign values to them. And you can see that when we assign values to them, it can be just a literal 42.36, or it can be an expression, miles divided by hours. And then the second to the last line is not a new thing for us. We're just printing a string literal. But the last line, you can print many types of, you can print any variable. If you're printing primitives, then they're always going to be evaluated, or they're always going to print out the way you would expect. So whatever MPH is, that calculation, the output is going to get sent to the console. Declaration is the first part, and when you're declaring a variable, you always give it a name or a type first and then a name, and you can only declare variables once. You can declare as many as you want, and you can do them in multiple places, but you can't declare the same variable in 2 different spots. All right, so assignment. When you are assigning a variable, you are putting a value into that slot that you told Java to reserve. So it has to match the variable's type. In certain cases, like if you're putting an integer into a double, well, I guess we'll get to that in a minute. But you can reassign to the same variable as many times as you want. That's right. This is what happens when you use a text editor instead of an actual IDE. So, okay, this is that same program that I had on the slide. The first thing I'm going to do is just compile it and run it. Java C, miles per hour calculator, and then Java, miles per hour calculator. All right, miles per hour, 38.5090909090991.
Do we need to be that?
What's that?
Do we need to be that accurate?
You don't, but that's how accurate a double will be. Okay, so I want to, in the program, say, okay, so we say miles per hour, and I'm actually going to say that miles down here, I'm going to reassign it, equals 12, exactly 12.0. And then I'm going to say hours, I'm going to say like 0.25. All right, so I'll save that and I will recompile it, and you can see my output from the previous time. Whoop. Okay, so why didn't it change? I changed the miles and the hours.
You didn't declare it after.
Look, I changed the miles and the hours, and I said miles per hour should be miles divided by hours. Why didn't it change?
Because it's doing the formal one. You need to, it cuts off as soon as it divides, right?
Yeah, so this is an important concept. This expression right here, miles per hours, it is not establishing a relationship. You're evaluating it at this line. So anything you do after this line doesn't have effect on what's stored in this memory location. If I want that to be updated, I need to say mph equals miles per hours, horses. And so even though it's the same thing, it's literally the same line of code, I need to run it again after I've changed what's in these two memory locations. Compile, run, 48. Great. I sped up. That still works. Great. Okay, so you can do declaration and assignment in the same statement. It doesn't need to be separate statements. You just simply say type, name, and then right afterwards equals value. They're still reassignable later on, and this is really good to do if there's a default value for something. Otherwise, well, I guess we'll get to that later. There's other variations. These are not totally common. The first example, double miles, comma hours. What that means is that those are both doubles and you're declaring them both in a single line. It does the same thing as saying double miles, semicolon, and then on the next line saying double hours, semicolon. You can even do like double miles equals and then a sign, and then comma, double hours equals a value, and then your semicolon terminator. That's one statement. It's the equivalent of doing two statements. It's a little bit confusing. I wouldn't recommend doing it that much. You can kind of mix and match where you declare one, you declare another, and give it a default value. Now we're getting super confusing. I wouldn't recommend, like I said, I wouldn't recommend this in general. Okay, there's a very common type of error, which is assigning or declaring a variable more than once. You cannot do that. If you want to reassign to an existing variable, that's fine, but you can't redeclare it by putting the type ahead of time. Java interprets that as create a variable named miles, and it's going to say, well, miles already exists. This isn't the Spider-Verse. There can't be multiple mileses. Okay. Assignment statements evaluate to a value. Chaining assignments is possible. Evaluation happens right to left by an equals operator, and this can be super confusing. Sorry, that first line should be x, comma, y, comma, z. So I've declared three variables, and then I can assign them all to each other like that. And what that actually means is that the 10 gets assigned to the z, and then whatever's in z, which is 10, gets assigned to y, and then that gets assigned to x. Chain assignment is allowed, but not recommended.
When would you need to do it?
You don't need to. It's just shorthand. If you have multiple things that you want to assign the same default value, you could do that. But I would recommend assigning them on individual lines, even if you're using the same default value, because then it's much clearer what you're trying to do. String concatenation. Okay, now we're getting to the good stuff. You can combine a string with other data into a longer string. And you just use the plus operator. It's the same operator that's used for addition, but this is not addition. It's called concatenation, or putting things in line, I guess. So if you look at the statement, within the println parentheses, I have a string literal, a plus sign, a number, and then a plus sign, another string literal. That will all get combined into one big string that says combining space 3 space items. Operator precedence still matters, so this sucks. Yeah, so if you look at this code, if 2 plus 3 plus LOL plus 7 plus 3 times, or 7 plus 2 times 3, it's actually going to start by adding 2 plus 3 and then combining that. Well, actually, the first thing it's going to do is that multiplication, because that's the order of operations. So it'll evaluate the 2 plus 3 to 6, and then it will do all the additions left to right, including concatenation. It groups concatenation with addition operators. So yeah. this is what happens. In the end, you wouldn't expect it, but you're going to get 5 LOL 76. Pretty stupid. Use parentheses. If you use parentheses, then it will evaluate the expressions you want. Okay, these are great. It's very common in Java to want to increase a number by a certain amount, or to increase a variable by a certain amount, and then reassign it back into that variable. So you could do it by saying like w equals w plus 1, or any of these other operations. That's perfectly valid and perfectly fine, but Java gives you and Java didn't invent this, this is actually really old. Java gives you a shortcut, plus equals, or minus equals, or times equals, or divides equals. And you should read this as w equals w plus 1, and x equals x minus 2, and so on and so forth. If you're only going to increment or decrement by 1, there are special increment and decrement operations, plus plus, minus minus. You can put it before and or after the variable name, and there's an important difference. Post-decrement and post-increment and post-decrement. So it modifies the original value after it is evaluated. So if you say int equals 0 or int x equals 0, int y equals x plus plus, x is going to equal 1 and y is going to equal 0 because the plus plus only happens after x is assigned to y. So x is 0 but when it's assigned to y, and then it increments x by 1. This is a little confusing. It's really useful when we get to for loops, but it can kind of bite you. If you want the opposite, then you just put the signs beforehand. And this is like actually another stupid programming joke. This is why C++ is called C++, because they took C and they added something to it and presumably made it better. But they didn't do the joke very well because they used the post increment operator. Oops, this slide should have been plus plus x. This one's x plus plus. They put the plus plus after the c, which means that they improved it after you used it, which is not what you want.
So it should have been plus plus c.
Yeah, it should have been plus plus c, because you want it to be better before you use it, right? Mm-hmm. Like I said, I don't have any good jokes. You can mix types. Java only allows one way if you're mixing doubles and integers. So if you look at this example, you can say like x, even though x is an integer, you can say x equals 3 times 4, or 3.4 times 2.9, and that's actually a problem. The Java compiler will complain, and it won't compile. But if you say y, which is a double, equals integer 2 plus integer 3, that's just fine. So the question is, why does Java have this rule? And the answer is that with a integer, it's easy to convert it to a decimal. You just add 0.00 after the end. But if you're going to convert a decimal into an integer, it's going to discard everything after the decimal place. And that's okay to do, but Java wants you to be explicit. Remember, Java enforces that you say what you're going to do when you're typing things, and also in this particular situation. You can do that, but you have to cast. Okay, so here's a common mistake, forgetting to cast something. So if you have 73 questions and somebody got 59 of them right, and you want to calculate the percent that they got on the test, you think, okay, well, I just divide the number they got, right, divided by the total questions, and multiply the result times 100. But in this case, the student gets a 0. Why? Because the teacher wrote the wrong grading program. It's going to take 59 divided by 3, which in integer division, 73, I said 3. 59 divided by 73. 73 does not go into 59, so you're going to get 0 times 100, 0 points. Okay, so what if I want to turn it into a double? Can't I just multiply it by 100.0? Well, the answer is what?
You have to cast it.
Yeah, the answer is that you still have to cast it. 100.0 still doesn't work. You have to put the 100 first, or you have to cast it. If you put the 100 first, the reason why this works as opposed to this is that, remember, divide and multiply are the same order of precedence when you're doing PEMDAS. Multiplication, division are the same precedence, so you're going to go left to right. So in this line, it'll do the division first, and then the multiplication, which converts it to a double. At the time you're doing the division, you're dividing integers. When you're doing this one, you do the multiplication first, and then it's doubles all the way. Because a double divided by an integer or times an integer is always going to be a double. Yeah, you can also cast, like you said. That's probably better. So yeah, in your code, and now we're getting to some really good stuff, you will very often want to do the same task over and over again, but with slight variations. So in this case, I want to print off the squares of these integer values 1, 2, 3, 4, and 5. So I can just do all these lines, but that's kind of, we're not adhering to the dry principle. We're repeating ourselves. Even though it's not exactly repeating yourselves, we still have tools to remove this repetition. And the answer is a loop. We can use a for loop. When you're when you're using a for loop, always remember to put a space after the word for. This is not a method call. This is a special thing. It's its own thing. There's 3 parts within the for loop, within the parentheses, and they're separated by semicolons. And the curly braces contain the code that's controlled by the for loop. You can actually do a for loop without the curly braces, but I don't recommend it. That can cause errors. Yes, the 3 important components of a for loop. Initialization, the continuation test, and the update. The initialization is where you start. It's like your starting state. Continuation is like what gets checked to see whether you go through the loop again. A loop is repeating over and over again until the continuation test fails. And then the update is what happens after each time you go through the loop. The body of the for loop has a series of statements, and they will get evaluated every time through the for loop. Make sure you increase indentation when you're inside a for loop. And yeah, the body is, again, everything. Oh, nope, don't shut down. The body, everything within the curly braces is the body of the loop. The flow of a for loop begins at the initialization step. If the test is true, then you execute the control statement, and then, well, control statements, there may be multiple statements within your for loop, and then you perform the update, and then you go back to checking whether the test is true. If the test is ever false, then you just end the for loop and you resume execution at the line after the for loop. So again, this is a situation where execution is not linear. Java will go top to bottom, but when you get to loops, it'll just repeat that, and then it'll jump to the end when the test fails. This is just syntax. These are grammar rules. Again, Java is a language. It has its own grammar rules. This is the structure that controls all the statements within the body. When you're tracing a for loop, tracing a for loop is an important skill to learn over time, but you can do it by either it helps to write it down, to have a piece of paper and a pencil or something, and to write down the conditions at any point in time. So in this case, we start with a variable of I equals to 1, continue while I is less than or equal to 5, and then we increase I by 1 each time. And this is the same as those 5 previous statements. where I said I squared equals, or I said 1 squared equals 1, 2 squared equals 4. This will output the same 5 statements. Not only that, we can change one single symbol on this, the 5, whoops, the 5 right here, and then we're doing squares of 1 through 6. It's a lot more convenient. All right. In this case, or in this execution, let's trace an execution of this for loop. We start with I less than 5, or checking whether phi is less than or equal to 5. It's true because we start at 1. 1 is less than 5 for sure. So we execute all the statements, which is going to print out 1 squared is 1, and then we increment I where it becomes 2 at the end of that first iteration. When we enter the loop again, I is now 2, 2 is still less than 5, so we execute all the statements, and then we increment it, it becomes 3. 3 is still less than 5, so we execute the body again, it becomes 4. And then 4 is also less than or equal to 5, so we go in the loop, execute all the statements, and then I becomes 5, and then we execute it one last time because 5 is truly less than or equal to 5. It's the last value that it is. But the important thing to note is that I actually gets incremented to 6. I is 6 at the very end of the loop execution. And that's the only way that the test fails, because 6 is not less than or equal to 5, so we stop executing the loop and we resume execution after the loop. Each cycle of the loop is an iteration. If you hear someone say iteration, that's what it means. And using for loops is called using iteration. There's another type of solving problems called, shoot, why can't I think of it? Recursion, geez. But we'll get to recursion eventually. Iteration has its advantages, recursion has its advantages. There's variations to for loop. Usage, you can use arbitrary integer expressions for initialization or for the test. You're not required to use the variable within the for loop, so you could do something 30 times. Like the last two for loops are equivalent, because whether I'm starting at 1 and going to 30 or starting at negative 30 and going to negative 1, I'm still doing something 30 times, and what I'm printing out doesn't depend on the value of I. Although it's kind of weird to do the negative stuff. You do you. Yeah, so for loops you can have for loops that literally never execute. In this one, I starts at 1, and 1 is not less than or equal to 0, so the body never executes. And then it just continues after the for loop. It's dead code. Like I said earlier, the curly braces are not technically required for for loops. If you're leaving them off, though, the for loop will only control the statement immediately after the for loop. So if you wrote this code here, the third line would only get executed once after that second line got executed 10 times, which is probably not what you meant when you wrote the code this way. So I would recommend never using the for loop without curly braces, simply because you may start with a for loop that only has one statement in it, and then later on you want to add more statements. But if you add a second statement and you forget that there's no curly braces, your second statement does nothing. Well, it does something, but it doesn't once. Okay, so system, we've been using system.out.println, and the ln stands for line. However, there's a method called system.out.print, and it does the same thing, only it doesn't start a new line when it prints. So this is the output for hello, how are you, if I use system.out.println, but if I use system.out.print, it's actually going to put it all on one line. I left off a space there after the comma and hello. So this can be useful if you're trying to print things out without putting them on multiple lines. Okay, nested for loops. This is where things get super tricky. So there's a for loop within a for loop here, and it's important to remember that you keep your variables straight. And by convention, the outer loop we use I, and the inner loop we use J. You can nest even deeper, and by convention, like the third level, it would be K. It's easier to read if you start from the inner loop and go out. This code here is the equivalent of going from 1 to 50 because we go 1 to 5 10 times. So in this case, a nested for loop isn't necessary. It's not important, but you can do it, and sometimes it's actually really useful. Keep your indentation correct. If you're not indenting correctly, it can get super confusing here. So this line of code here, what does it do?
It just prints an asterisk 50 times or something.
All right, but what's it going to look like on the output?
And just a line of asterisks followed by just
Actually,
it's just an asterisk, empty line asterisk.
it'll be like if you do system out print, it does 5 asterisks in a line, and then the next line is println, so it'll end that line, go to a new line, and then it'll print 5 asterisks, new line, 5 asterisks, new line. So you have 10 lines of 5 asterisks each. Okay, so I'm changing here. There's very subtle differences. So if I go in your inner loop, you can reference the outer variable. So in this first one, I do the inner loop from 1 to 5 and the outer loop from 1 to 10. But in the second example, I'm doing the inner loop from 1 to I and the outer loop from 1 to 10. So this is not going to do 10 lines of 5 asterisks anymore. What's it going to do?
I'm just going to keep increasing the asterisks.
Starting by how many?
1.
Yeah, so it'll do 1 asterisk, 2, 3, all the way to 10. All right, so an important concept to understand at this point, because we've danced around it a bunch, is scope. Scope is the part of a program where a particular declaration is valid. So a good guide to use is that the scope of a variable begins where you declare it, where you say like int x or double v or whatever, and then it ends at the next closing curly brace. Well, at the next closing curly brace that encloses it. That's a little complicated, but we'll get to that. The scope does not begin at its beginning curly brace because it begins where it's declared. A local variable is a variable that's declared inside of a method instead of a class, and it's only accessible to that method. So you can't if you have a variable in one method, it can't be used in a different method unless it's declared somewhere else where both methods can see it. And we'll get to that eventually. And localizing a variable means that you're declaring it in the innermost, most local scope possible, which is good. You should always keep things as close to where they're needed and not like out where other places and people can access them and modify them. So here's a scope example. Int x and int y are inside the main method. Inside the main method, we call compute sum, but in compute sum, we're trying to like reference x and y. But this is not going to work because the scope of x, it begins where it's declared right here, and it ends at this curly brace. It can't be seen down here. And the same goes for y. It begins right here at this line, and it ends right here. So the scope does not enclose compute sum, this method, so you can't reference it at all. Here's another scope example. Variables declared within a for loop are not accessible outside the for loop. So this int squared is declared inside this for loop, and it ends at its closing curly brace. That means that by the time we get to this line, int squared is no longer visible, so we cannot reference it. This will not compile. All right, so here is a solution to what we're trying to do in the previous problem, or the previous slide. we can reference squared now because it's no longer declared inside the for loop. It's assigned in the for loop, but we've declared it before the for loop. So it's declared here. That means that its enclosing curly brace is this one down here, which is after the line where we want to use it. So this is good. Okay, here's another scope example. The variable and the loop initialization are valid throughout the entire body of the loop. So for loops are special. You can kind of imagine, where's my cursor? Come on. It's declared right here in the parentheses, but you can kind of imagine that it's actually declared on the next line. It's valid within the whole body. So I is valid to this whole thing. And that means that this is legal. Even though we're using declaring the same variable twice, it's totally legal to do because it's different scopes. This one's scope is inside this for loop. This one's scope is inside this for loop. Those are different variables. All right, so yeah. If you were trying to do a nested for loop and you're referencing the same variable, that is not okay, unlike the previous slide, because this for loop is within the scope of the outer for loop. You cannot redeclare a variable that already exists. You can assign it, but you cannot redeclare it. The solution is just to give it a different name, which we've seen. We use I, start with I, go to J, and K, L. You can move int I outside of the for loop, and you declare it once, and now it can be used by both these. Is this okay?
No,
Why not?
because they're both gonna be changing it.
Yeah, they're both changing. They're not. We don't want them to be doing this. Like, this is going to be utter chaos.
Otter cage.
So what if like in this case, if we go from 1 to 5 on the outer one and then 1 to 10, this actually would work, I believe, because we start at 1 and then we go to 5. So I starts at 1. And then here it gets overwritten to 1 again, initially.
Go infinitely?
And then actually I'm not sure if this goes infinite or not.
Would it be stuck at, would it be at 10 and then never repeat the first line again?
We should try it. Let's do this.
Oh, yeah.
Oh, whoops. I'm totally going to try it. Oh, come on now.
Computer crashes. TV crashes.
TV crashes.
Lab crashes. Opens a black hole.
All right, so we'll do, oops, not space, public, static, void, main, string, array, args, open and close brackets, space, 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 whoops, int I equals 1. For I equals 1, I less than, was it, the outer loop was 5, I believe?
Mm-hmm.
I plus plus, whoops, and then,
Wait. Do you have space between the...
oops, that's a comma, that should be a,
No, you need a space between the 5 and the equals?
well, you don't need it, but yes, you should have it. It's a lot tight
No,
here.
it's not very good. Code grammar.
I less than or equal to 10
You
I
just
plus
wrote 10
plus.
twice.
Oh, I'll fix it. Ah! This is hard. I'm looking, if you're watching the video, I'm actually looking over my shoulder as I'm coding because the screen is behind me. Okay, so yeah, this should be 1.
Glory of science.
Okay. So what? I guess we can ask, why does that happen? Why does it go from 1 to 10?
Okay, why does that happen?
What's that?
Why does that happen?
The second loop to get to 10 and the first loop is already plus 5.
Oh yeah. Okay, so that makes sense because we start at 1, and 1 is less than or equal to 5, so we enter this loop. Then we reassign I with 1. It's already 1, but we assign it anyways. And then while I is less than or equal to 10, we execute this. So it should do that 10 times, and then it'll resume execution up here. But I is now 10, and 10 is going to be not less than or equal to 5. So we'll exit the outer loop. So the outer loop executes once, the inner loop executes 10 times. Okay.
Can you make an infinite loop though?
Well, let's try this one.
Oh no. Oh, nice. What is gonna happen?
This is just as simple as reversing them, right?
Yeah.
10.
What's gonna happen?
What's our expectation here? So if it goes,
Black hole.
so it's going to end at 5, and then okay, yeah, this is going to be fun. So we have to recompile. I'm used to using the Linux command prompt, but whatever. Okay, Java Fruit Loop. Yep. We have an infinite loop that's going from 1 to 5 over and over again, and it will never stop, ever, until I do Control C.
Do it again.
Infinite loops are actually kind of sort of used for things like video games, where you have a loop that's running forever until something interrupts it.
You mean
Sort of
like Portal? You know when you put a portal on the ceiling and on the floor?
Yeah,
and
you
fall
can
through
think
it?
like that. But like you have a loop that's running over and over again and checking controller input and writing frames. And the faster the loop, the better your game experience is probably going to be. That's how you get all those FPSs in your FPSs.
Oh, wow. Hello
We did it. We got our infinite loop. You can do the same thing by just starting at 1 and saying if it's
Hello
like
forever.
greater than
Can we
or
do
equal
that
to
one
0.
now?
Hello forever. No, it's the same thing.
I would just say hello forever.
Okay, so infinite loops. Try to avoid them. If you're executing on the command line, you can do Control C to cancel your program if you ever get stuck in an infinite loop.
Never stop.
Pseudocode. Pseudocode is an English-like description of algorithms. It's like you're sort of writing code line by line, but you're writing the instructions in English. And you don't have to use proper grammar. You can use sentence fragments and whatever. And it helps you to sort of like write an outline for your code. And you can start by like writing things in very general statements and then breaking those general statements down into specific statements. Programming with pseudocode is exactly that process. You just keep going until eventually you can very easily convert your pseudocode into actual code. All right, so here's a pseudocode example. Draw a box with 50 lines and 30 columns of asterisks.
What?
Well, 50 lines and 30 columns of asterisks.
Okay.
So you could write this. It looks like a for loop, but you're writing in English. This is not Java. For each of the 50 lines, draw a line with 30 asterisks. And there's no real rules for pseudocode.
That looks like Scratch.
You should keep your pseudocode succinct and like easy to understand by yourself. There's no medals for like using lots of words. And then, so for each of 50 lines, draw a line of 30 asterisks. Well, drawing a line of 30 asterisks, that's a fun word to say, is something that we need to break down even further. So for each of the 30 columns, write an asterisk on the same line, and then after that for loop, go to a new output line. And at this point, we have something that can be easily converted into Java code. Boom. So there's pseudocode, Java code.
Can we run that? I want to see a big square.
We'll get to stuff that we're going to run.
Cool.
Other for loop variation. Oh no! Are you okay? If you have man down. So one of the variations on loops is that you can decrement. You don't have to use I++, you can use I minus. Sometimes it's more useful to count down than up, like if you're starting at a high number and going down. All right, and now another fun concept, class constants. So remember how I said that if you have a variable declared in one method, it can't be used in a different method? Well, if you want something to be used in multiple methods, it can be a class constant. Class constants are in the form of final, and then the variable declaration, and then the assignment. A final, so this is an object-oriented class constant. It can be accessed anywhere in the class. The scope is the entire class. If we want to use it in a static method, we have to add the static modifier to the constant as well. So public final static, and then the same things we've been doing for all of our variables. The type, which is double, identifier, which is weight, and the expression, which could be a literal double like this, or it could be a mathematical expression.
Static can't be changed.
Static doesn't necessarily mean it can't be changed. It just means it can be used in a non-object-oriented type of way, which we haven't quite got to object-oriented programming yet. But when you have constants like this, you should be capitalizing them, their names, all caps. That's just it's a way when people see referencing it that like, oh, that's a constant. That's not something that changes. All right, so we have another problem, a complex figure. This seems way simpler, but we're going to solve this with for loops.
Can't we just?
Can't we just?
Triangle.
So yeah, what are we going to do?
Well, first, you just need to print the first. First, you just need to print the top.
Yeah, print the top.
And then
Well, if you look at these lines, these are all actually the exact same characters
yeah, they're just
for the top ones.
minusing spaces.
Yeah, well, they're not even minusing spaces, they're moving them around. Look here, I'll show you. On the first line, move my cursor up. So there's a vertical, that's called a pipe character, but we'll just call it a vertical line. And then there's this slash, and there's 1, 2, 3, 4 different spaces, and then the other slash, and then the pipe. So there was four spaces total. All right, so here we go past the pipe, 1 space, slash, 2 spaces, 3 spaces, slash, 4 spaces.
I'm not sure.
All right. And then 1, 2, 1 space, 2 spaces, slash, 3 spaces, 4 spaces. So it's always 4 spaces.
You could just find a way to have a variable that's just a space, like a character, just a space.
Draw figures again, because we already have a draw figures.java. Or I could call it draw figures too, but I don't know.
And creativity.
Public static void main string array args. Oh, there's 2 spaces args. All right, so let's do our pseudocode.
With the spaces outward.
Even simpler than that, we can break this down into 2 pieces, right?
Yeah.
Well, I guess we can break it into 3 different things. So there's drawing the top and the bottom.
Yeah, that's easy.
Maybe we could start with that. Whoops, fra. Draw a horizontal line. And we're actually going to do that at the start and at the end.
Okay.
And then we're going to say,
Draw part of.
what do you want? What should we call the top part? I guess it's an M and a W. Draw M. Draw W.
Okay.
So that's the M, and then that's the W. All right, so I guess we can start by saying,
Draw slashes and M shape.
what's that? Why don't we, okay, so drawing a horizontal line, how can this be broken down?
Print line.
Well, before we even get to printing,
Draw a line that starts with a plus, has 6 minuses, and then ends with a plus.
yeah, so drawing a horizontal line will be like output a plus, output a plus, output a new line. But between those pluses, we're going to say for each of,
Just repeat it 7 times.
is it, we said 7? 1, 2, 3, 4, 5, 6. For each of 6 minuses, output a minus. Right?
Yeah.
And that's the whole thing for,
And just copy it again.
yeah, well, we'll leave this for now. Actually, what we can do is create our method names and then move the pseudocode into the methods. Public, static, void. What should this method be called? Draw line.
Line.
Oh, line. Okay, I like your succinctness. All right, and so we have all of this that goes in line. All right. And so that means that drawing a horizontal line is now just going to be a method call.
But you need the line terminator.
Correct, thank you. I actually didn't miss that on purpose. I was not really trying to teach you something. Public, static, void. Should we just call it M?
Yeah.
My hands are... You can have single letter method names like that. So there's M, and then we'll...
I'm open to suggestions on how to do this.
And then there's W. And let's just call those methods M, W.
Now, how will we work on the static void line thing first?
This one? Wait, which one do you want to work on?
Line.
Well, this one's already broken down into
Mhm.
code that we can do pretty easy. Yeah, sure, let's do it. All right, so let's start with outputting a plus.
Print plus.
All right,
System output plus. Wait.
dot print. We can actually either use a character like that or the double quotes. System out. So that's outputting a plus.
And then just do a really simple,
Whoopsie.
really simple for loop.
All right, so if I wanted to do for each of 6 minuses,
I guess I equals
int I equals
1,
I less than or equal to
6.
6, I plus plus, and then all this boilerplate. Great. All right, so we output a minus, right?
Mm-hmm.
Rpint. Great, and then that takes care of this. And then we output a new line.
System out print line.
All right, let's save and compile this. Draw figures again.
You need to make sure it's, oh, never mind.
Okay.
You need to comment stuff out.
Whoops, what is... I can't remember how to clear the terminal. Okay. Boom. 1, 2, 3, 4, 5, 6. Great, we did it. Well, stage 1 complete. All right, start with the W. So we'll do pseudocode again.
Print pipe.
Well, let's figure out what it is we're doing.
Printing a pipe, and then move every time we do it. We move a slash out, or no, we move a space out. Well, we move the.
Yeah, let's focus on the pipes first. Every line begins and ends with a pipe, right? So for each of 3 lines, output a pipe,
Then
and then there's going to be something here, and then there's
make
do other stuff, and then output a pipe, and then after the for loop, we output a new line. But this other stuff is where it gets tricky. So if we look at the complex figure, it's always a slash, or a, a front slash and a backslash. So let's actually start and number these. So the first time through the loop, I is 1. The second time through the loop, I is 2. And the third time through the loop, I is 3. Can we come up with a relation between the spaces and these numbers? So how many spaces do we do between the pipe and this first slash?
none.
None.
At the beginning, the spaces, there are 4 spaces in the middle. Then you move 2 of them.
Right,
out.
but hold on, let's just do it one step at a time. The number of spaces between the pipe and the first slash is 0 when I is 1. When I is 2, it's 1 space. When I is 3, it's 1, 2 spaces. So what's our mathematical relation?
Increase the outside spaces by 1 every time.
But what is it in relation to I?
It's I minus 1.
There you go, I minus 1 spaces. And we do the same thing after the, wait, is that backslash or front slash? I can never remember the difference. Whatever.
And the one that goes to the right, I guess.
Okay, so we'll say we want to output a pipe and then output line number, wait, for each minus 1 spaces.
And then output a slash. Output the whatever slash.
Output a this, and then after that, output a that. Okay, and then going back to our complex figure, What are the spaces in between? How do they relate to the numbers on the right? 1, 2, 3, 4. 1, 2, and 0.
So is it,
So it's 4, 2, and 0. What's the mathematical relationship?
it keeps, it starts from 4 and subtracts 2.
Well, what's the mathematical relationship between these horizontal numbers?
I'm not sure. I'm not sure how to put it into words. Maybe somebody online has.
Does anyone, I don't know if,
Is it 24%, 1, 3, 4.
what if we said, I think we're going to have to do something twice because it doubles each time, right?
Yeah.
So what if we halved those numbers? 2, 1, and 0. Is there a mathematical relationship now between 1, 2,
Yeah.
and 3 and 2, 1, and 0?
You just do, you just add. No. You.
2 is 3 minus 1.
Okay.
1 is 3 minus 2.
So you subtract the number from 3 and multiply by 2.
Right. All right. So we do the subtraction and then the multiplication.
Mm-hmm.
So we'll say get a number. Well, we can just do this. Output 3 minus 3. Well, not 3, sorry. 3 minus line number. Line number times 2 spaces.
That's doable now.
All right, cool. So let's start by doing the pipes. I can do those. Oopsie. All right, and then I can do the slashes. I think that's the one I have to escape. Is that true? We'll find out.
Mm-hmm.
Great. So now output line number minus 1 spaces. So this can actually become for each of line number output a space. And our line number is it goes from
3 to 1.
let's populate this. Int I equals 0 or 1. I less than equal to 3. I plus plus. So then this becomes I, right? Int j equals 1, j less than or equal to I, because that's our line number, j plus plus. I have to like force myself to not type I again, because that's a very common mistake. And then I want to output a space.
Print space.
System.out.print. And I want to do that before or after the first one, and then before the last one. Okay. And now this one I need to break down a little bit more.
Hey, guys doing? Hey, good. How are you? Good. You're up to?
Learning to code. Yeah.
Learning the code.
Yeah,
Wonderful. We all need to learn how to do that.
that's right.
Have a good one. Thank you, sir.
Each of line number actually we want to go from 4
3 minus
each yeah, we'll just do 3 minus line number output space. Well, I know how to output a space. That's right there. And
It'd just be I equals 1.
well, I don't want to use I because remember this one.
K.
Well, I can actually reuse J because I'm outside the scope.
Okay.
Like we're on the
J
same level.
equals 1.
J equals 1.
And then while J is
less than or equal to 3.
minus.
J plus plus. Actually, we can do this a different way. 3 minus the line number. So we can actually, well, here, let me just do it on a new line so we don't lose our place.
I don't understand.
You don't understand?
Yeah, this is confusing. Wait, wouldn't it be just J equals 3 minus J?
So we start at, let's see here. So we want to do it, our total number is going to be 3 minus I times 2, right?
Wouldn't it be 4? Oh, never mind.
So J equals 1, J less than or equal to, we'll do this in reverse, 2 times 3 minus I, right? Because that's our I is our line number.
Yeah, I think so. I want to say it makes sense, but it's hard.
Yeah, this is our first like fiddly complex expression.
So what'll it do now?
Well, we can compile it and run it. So we start at 1, and then if j is less than or equal to 2 times 3 minus I, so I is going to start at, the first time through, I is going to be 1.
So it's 4.
So it's going to be oh, I used the wrong, I escaped the, wait, unclosed character literal.
Oh, looks like you can't. Oh, you forgot the 3 minus line number.
Oh yeah, that's right.
So apparently you do need the double whatevers.
Probably. Let's recompile. Boom. So this one is wrong. So this one needs to get escaped, the other one doesn't.
Oh, that one needs a parentheses.
What needs a parenthesis? What did I forget?
Oh, right there, the J plus plus.
J plus plus.
And above it.
Oh, yes. Thank you. Good catch.
How could you have forgotten?
Whoops. Ah, okay. Cannot find symbol. I.
34.
Why can't it find I here? Oh. Because, wait. But that's also okay. Cannot find symbol I.
Are they
Oh.
all inside?
I think I didn't. Yeah. Do you see what I did? I forgot my curly brace. So that means that the body of this for loop is only this line. And that's why I doesn't exist at this line. I made the same mistake that I said not to make.
Congrats, Dad. You played yourself.
No, I did that on purpose as a learning tool.
Yeah, we believe you.
Okay, it compiles.
Yay.
Does it do what we want?
No.
Almost. What's
No.
wrong?
It's adding an extra space.
Okay, so the inner spaces are okay, but it's those spaces that are wrong. Let's double check our logic for those ones.
Shouldn't it be the line minus one? Where's the outside lines again?
Oh yeah, we could figure out this.
Because it equals 1, so it, not, well, if you had, do you get rid of the equal sign at work, do you think? Or do you always have to, in Java, always have to equals?
Oh, we could use equals, or we could just say I minus 1. Here, let's figure out our relationship again. So we nailed this. So our line numbers here are, yeah, line 1, line 2, and line 3. And what we want is 0 spaces, and then we want 1 space, and then we want 2 spaces, because we're talking about the spaces there.
Subtract the line number.
Yeah, so it should be I minus 1. I believe that's right.
Mm-hmm.
Does Java always use less than equals, or do you ever just use less than?
Less than is actually more common.
Oh, okay.
Less than equals is a little bit easier because well, conceptually it's easier right now because we haven't gone over that Java is 0 indexed.
Gotcha.
What does that mean?
We'll get to it. Ah, there we go. We got our M. And so now the W should be pretty similar.
It's the same thing but reversed. Again.
Yeah, let's not rewrite the whole thing. It should, I mean, the pipe part is going to be the same. But we just do we switch the top and the bottom, right?
Mm-hmm.
So what we could do is, well, never mind. I don't think it's that similar enough yet.
It's talking about switches and switching the characters.
Well, our counting also switches. Let's see, because let's do our line number. So it's 1, 2, and whoops, 3.
Yeah.
And the number of spaces is
You're
1,
right.
2, 1, 2, and then 1, and then 0.
Dad,
So-
I think you're a valve employee. You can't count to 3.
2, 1, and 0. So that's the spaces between the pipe and the cymbal. So we want to go, I guess, what's our relationship then? It's
Weird.
3 minus line number, right?
Yes.
Because it's 3 minus 1 is 2, 3 minus 2 is 1, 3 minus 3 is 0. All right, so the number of spaces is going to be equal to, like we said,
No, it's 3 minus I.
Yeah.
I minus 3.
3 minus I.
And it would probably be, I guess, I minus 1 for the one you just changed, right?
I think, well, hold on just a sec. We'll double check that. Let me swap these symbols. Okay, so this is definitely wrong.
What?
So we start with 0, and then we go 1, 2, and then it's 1, 2, 3, 4. Whoops. So we start at 0, 2, and then 4. So again, it's going to be 2 times something, I assume. So let's divide this by 2. 0,
Wait, I think I got it.
1,
It's the.
2.
It's the line number minus 1 times 2.
Yeah, line number minus 1,
I'm smart.
and then we multiply it by 2.
Math.
All right, so our line number is I, and then we minus the 1. Whoops, not negative 1.
Are you sure it's I or is it J?
It's I,
Okay.
because the outer loop controls our line number. But we want to multiply the whole thing times 2. So just like that, right?
No, parentheses.
Okay, good.
PEMDAS. PEMDAS, PEMDAS, PEMDAS.
All right. So we can go through real quick. So we'll start at 0, or starts at 1, and I is going to be 1. So 2 times 1 minus 1 is going to be 0. So is 1 less than or equal to 0? No. So the first time through we get 0 spaces. Second time through, I is 2. So 2 minus 1 is 1. 1 times 2 is 2. And yeah, 2 is less than or equal to 2. And then the third time around, and so we'll get a space, because J starts at 2 and then increases to 3, and then it's no more spaces. Third time around on the outer loop, I is 3. 3 minus 1 is 2. 2 times 2 is 4. And so I starts at 1, prints out a space. J gets increased to 2, prints out a space. Gets increased to 3, prints out a space. Gets increased to 4, prints out a space. And then it gets increased to 5, and there's no more spaces. So we'll get 4 spaces that last time through. Let's try and see if that's actually true.
I'm not sure who's.
Yay!
Yeah!
We did it!
We are the champions.
So this seems very useless to do this sort of thing, but fitting problems into loops is actually incredibly useful, especially for robotics. There's certain tasks you're going to need to repeat, and you may need to repeat them in slightly different ways each time based off of a changing input. Well, thank you so much for joining me.